Okay, and this is the last section of this particular part of the module, classifying reactions in aqueous solution. The goals are to recognize the key characteristics of four types of reactions in aqueous solution and to identify reactions based on these characteristics. Also to predict products for precipitation, acid-base, and gas-forming reactions, and write balanced chemical equations and net ionic equations for these reactions. So, classifying reactions in aqueous solution. So here's how I do it. For precipitation reaction, two aqueous ionic solutions combine to make an ionic solid. Aqueous ionic, solid ionic. Redox reaction. You look for a change in the charge on the element. So charge on element changes. Often a pure element is involved. So when I see copper here in a pure form, and I see copper here in an impure form or in a substance, I know that the oxidation number has changed. Here we have an acid-base reaction. You look for an acid and a base. Acid-base reaction. Gas forming, you look for gas being formed, but it's not your typical redox acid-base or precipitation. For the gas forming, you're basically looking for a carbonate, a sulfide, a sulfite, or ammonium. One of those four things. Okay, so let's take a look here at some problems. Complete and balance each of the following equations for those exchange reactions, or for these exchange reactions, and classify each as a precipitation, acid-base, or gas forming. So in this one here, I'm thinking to myself, this is not an acid-base because I don't see an acid and a base. I don't know if it's redox, but I'm going to go for maybe a precipitation reaction or for gas forming. Now for gas forming, sulfides can react, but they react with acids. This is not an acid, so this is not gas forming. So that leads me to the conclusion that this is probably a precipitation reaction. So for precipitation reaction, I know that sodium ion will not be part of the precipitate, but the copper probably will be. I know the nitrate will not be part of the precipitate, but I know that the sulfide probably will be. And in this particular case, since we know the copper is a +2 and we know the sulfur is a -2, we get copper 2 sulfide, and this will be our solid. What happens with the remaining ions? Well, the two sodiums and the two nitrates form sodium nitrate, but two of them, and this is aqueous. So this is a precipitation reaction. How about this one? Well, that is an acid, but that's not a base, but it is a sulfite. So I remember for these reactions, you're going to get SO2 for sure. And I believe you also get water, right? So what remains is, well, let's see. We can help to, it might help us to balance this. We have two hydrogens here and only one, so I'm going to put a 2 here. So I've taken care of the SO3, there it is. The other oxygen in SO3 has become an oxygen in water. These two hydrogens are here. The only thing I haven't taken care of is the two sodiums and the two chlorides. So I'm going to write this. And of course, that's aqueous. So how does that look? It looks silly because we don't write ionic compounds like that. How does this look instead? Much better. So what is this? This is a gas forming. How about this last one? Well, that definitely looks like an acid, and that looks like a base. Here I have one proton, here I have one hydroxide, so I'm going to make one water. And the leftovers are the sodium and the perchlorate. This will be aqueous because of the sodium. The perchlorate also helps, and this is going to be an acid base. Okay, there we go. Next, we have balance the following equations, and then classify each as a precipitation, Acid-base or gas-forming reaction. Well, this is clearly acid-base, right? Base acid. I need 2 hydrogens for 2 hydroxides, and I'll get 2 water. 2, 2, 2. 1 leftover barium, 2 leftover chlorides, we're done. This is not an acid base. This is a gas forming. I have the carbonate and an acid. So for that, I need 2 hydrogens with 1 carbonate. There's the carbonate, 1 hydrogen, now there's 2. So that explains the H2O and the CO2. 1 cobalt left over, 2 nitrates, and we're done. This one, not a gas forming, not a acid base. So this has got to be precipitation, right? Will sodium be part of the solid? No. Will copper? Yep. And then phosphate. So this is a precipitation reaction. Oh, I should have labeled the other ones. So this one is acid base, and this one is gas forming. And now this one here, let's balance it. 3 sodiums, 1 phosphate, 2 phosphates. So I probably need to put a 2 there, but if I put a 2 there, now I've got to change this to 6. Okay, so 6 sodiums, 2 phosphate, 2 phosphate, 3 and 3, and 6 nitrate and 6 nitrate. So there we go. So don't be afraid to change your coefficient when you're balancing if it doesn't work out well the first time. Classify each of the following reactions as precipitation, acid base, or gas forming. Show states for the products, and then balance the completed equation. Write the net ionic equation. So there's a lot going on here. So we need to figure out what type of reaction, get the state, and then write the balanced reaction and the net ionic. Okay, so this one here, if we take a look, I don't see CO2 or H2O or any gases, if you were. So not a gas forming. These aren't acids and bases, so I don't think this is an acid-base reaction. Another reason to eliminate the gas forming is although this is a metal sulfide, that's not an acid. So this has got to be a precipitation reaction. And I know this is soluble, so this has got to be the solid. And here, 1 manganese, 2 chlorines, 1 chlorine. So I put a 2 here. 2 sodiums, 1 sulfur, 1 sulfur. So what is the key to writing a net ionic reaction for a precipitation reaction? That's right. Write down the solid, then write down the ions that make the solid. And of course, they are aqueous. So this one is a precipitation reaction. This one looks like it could be a gas forming reaction because I see the CO3 here, but this is not an acid, so it's not a gas forming. So for acid base, I don't see an acid and a base, so this has to be a precipitation. So I know this is aqueous because of the potassium, so this has to be a solid. 2 potassiums, 1, so I put a 2 here. 1 carbonate, 1. 1 zinc, 1. 2 chlorines, it's balanced. And this is a precipitation reaction. For the net ionic, once again, it's really easy. Write the solid first, then write down the ions separately as aqueous. And you're done. Okay. Balance each of the following equations and classify them as precipitation, acid-base, gas forming, or redox reactions. Show states for reactants and products. So for this one, what am I thinking? Well, I'm thinking that this is hydrogen sulfide, and this is actually the backwards of a gas forming reaction. What I mean by that is this is a gas, this is aqueous, this is a solid because of that, this is aqueous, and here you have a metal sulfide plus an acid making a metal salt plus hydrogen sulfide. So this is actually a gas forming, as it were, but backwards. Ooh, your book is tricky. Okay, to balance it, we put a 2 here, and that's balanced. All right, next, let's take a look. We have these two. Well, that's clearly an acid and a base, so this is an acid-base reaction. I'm going to put a 3 here so that I have 3 hydroxides with my 3 hydrogens to make 3 waters. Water is a liquid. This is aqueous because of the potassium. This is aqueous because you're just going to put down all acids are aqueous, and this will be aqueous. Now let's make sure that everything's balanced. 3 hydrogens plus 3 hydrogens for 6, 6 there. 1 phosphorus, 1 phosphorus, 4 oxygens plus 3 for 7, 4 oxygens plus 3 for 7, we're balanced. Now this one, I see a pure element, so I'm thinking redox. This is a redox reaction. So for a redox reaction, all we have to do is kind of look to balance it. 1 calcium, 1 calcium, 1 hydrogen, 2 hydrogens, put a 2 there, 2 bromides, 2 bromides. This is a solid. This is going to be an aqueous solution. This is going to be a gas, and this is going to be aqueous. This one looks like a base, but that's not an acid. So it's not an acid-base reaction. This is not a gas forming reaction. And it's not a redox reaction because I don't see any pure elements and I don't see any changes in charge. So I'm thinking this must be a precipitation reaction. So aqueous, aqueous, here solid because hydroxides are insoluble, and this is aqueous. And to balance, 1 magnesium, 2 chlorines, 2 chlorines, 1 sodium, now 2 sodiums and 2 sodiums, and 2 hydroxides and 2 hydroxides. And this is a precipitation. So 1 of each. Okay. And this is the last one for this particular section. Products in several reactions are given below. Identify their reactants labeled X and Y, and write the complete balanced equation for each reaction. So here you can see we get water and a salt, so I'm thinking acid base. So what's the acid and base that I could use to make these? Well, I think that the acid has to start with hydrogen, and it has to have a counter ion, a negatively charged ion. And the only thing I can see in here is maybe that Br. So there's my acid. So what's my base going to be? Well, the base has to have some sort of metal ion to begin with, and then hydroxide. So here I'm thinking that, and this is actually a solid. Okay, would this give me H2O? And the answer is yeah, but I should put a 2 here, and then I'll get 2 H2O plus calcium bromide aqueous. Okay. How about this one here? This is clearly a gas forming reaction, so I need to have some sort of metal carbonate to make this. Now, what is the metal carbonate going to be made out of? The metal has to be magnesium. So I'm going to start off with magnesium, okay? And I don't know whether it's CO3 or HCO3. I'm going to add an acid to it. What acid? Well, here's my counter ion, so that's the acid. So the magnesium from here and the acid from here. And let's see, we need 2 hydrogens for one of these, and that would make sense because then you need 2 nitrates. So here's the balanced reaction. So this first one was acid base. This one's a gas forming. Now let's take a look at this one. Look, I got a solid. I'm thinking precipitation. So precipitation means I basically have to switch ions. That is to say, I'm going to start off with barium chloride and mix it with sodium sulfate. To get barium sulfate and sodium chloride. And you might wonder, well, why did I put 2 chlorines here? Well, to me, it's kind of obvious, and for you, it should be obvious. That is a +2 ion. Chlorines are -1, so you have to have 2 chlorines for every 1 barium. All right, and the same goes for the sodium sulfate. The sulfate is a -2, sodiums are +1, so you have to have 2 sodiums. So to finish balancing this, we have to put a 2 right there, and it'll be balanced. And this is a precipitation reaction. And lastly, what is this one? We're making an ammonium compound. This looks like it could be just an acid-base reaction between ammonia and water, where we'll make ammonium hydroxide. So that one was really pretty simple if we understand that ammonia can act as a base to react with this to make this acid base. So this is your typical Bronsted-Lowry acid base type reaction. All right, that's it. Thank you for listening.